This is the video for question 13 from section 1 of the 2018 ENGAA paper. In this question, we're given a full-size pillar and we're told it has a volume of 12 pi cubic metres. And we're told about a scale model of this pillar. And the lengths of this model are scaled 1 to 40. And we're told the model has a density of 4/3 of a gram per centimetre cubed. And we're asked to deduce from this, what is the model's total mass in grams? So how do we start? We've been given all this information. How does it all relate? Well, first things first, what's the equation relating these quantities? Mass, density, volume? Well, this will be very important for everything we're going to do. And we're asked to find the model's mass in grams. And what do we already know about the model? We know the density of the model. So all we need is the volume of the model. So let's try and go about that. So we already know about the volume of the big model. We know it's 12 pi metres cubed. And we know the lengths are scaled 1 to 40. So that means every dimension, length dimension on our model pillar is 40 times smaller. So the volume will be 1/40 cubed as a factor smaller because all the dimensions are a 40th of what they were. So we know the volume of the model, we'll call this Vn, is equal to 12 pi times 1/40 cubed metres cubed. Now, this is a pretty horrible number, but now it's time to look at the units. So we've got this full-size pillar in metres cubed, but if we're given here, our density is 4/3 gram per centimetre cubed. So if we convert this into centimetres cubed, not only does it agree with this, the number will also be more reasonable and not so stupidly small. And indeed, that is the case. We get this if we convert it to centimetres cubed. This comes from the fact there's 100 centimetres in a metre, so the scaling factor between centimetres and metres will be that cubed, so 100 cubed. And this, again, we don't have to calculate it all. We can bring the 100 inside because this is cubed and this is cubed. So we get to this, and we can simplify 100 over 40, which is great, 5/2. So we've got this centimetres cubed, and we can have a go at simplifying this a little bit. We can expand out 5/2, and 12/8, well, that can be a little bit better, that's 3/2. So we get to this in the end, and it doesn't look like it's going much further. And it's a little bit ugly, this, but no worries, because this isn't our final answer. We're actually asked for the mass, aren't we? So let's work that out now. So we've got the volume of the model here, and we need the mass of the model. So the model mass is equal to the density, which is 4/3, times this volume we just calculated. And this is in grams, because it's grams per centimetre cubed, and centimetre cubed here. So all the units line up, and this comes out. Good thing is, lots of this cancels. The 3's cancel here, and 4/2 is 2, so we simply get this. 2 times 125 is 250. So we're going to get 250 pi grams, which is good news because 250 pi is one of our answers in the multiple choice. In fact, it's E, and so our answer is E.